All right, welcome everyone. Today, we're going to tackle one of the most critical parts of any Cisco ACI deployment, and that is, how do you actually connect your fabric to the outside world? Let's get right into it. So, you've done all the hard work, right? Your ACI fabric is up, your applications are running inside, but now what? That fabric is kind of like its own little island. It's an amazing policy-driven world, which is fantastic for security and automation, but it's still an island. We've got to build a secure and scalable bridge to connect it to everything else. You know, your corporate WAN, the internet, maybe even another data center.
Okay, so here's what we've got on the agenda. First up, we'll break down what an L3 out actually is. Then we're going to follow the routes, see how they get in and out of the fabric. After that, we'll look at the actual configuration model, the bits and pieces you need to build. We'll talk about how to define and classify your external networks, and then we'll hit on something super important, contracts. And to wrap it all up, we'll walk through a real-world OSPF example to see how it all fits together.
All right, let's start with the basics. What exactly is this thing called an L3 out? So at its heart, the L3 out is ACI's official, purpose-built bridge to the outside world. But it's more than just a bunch of interface commands. It's really a policy object, a container, if you will, that manages that entire routing conversation between your fabric and any external Layer 3 device. Could be a WAN router, could be a firewall, doesn't matter. Now, where does this connection actually happen? Well, physically, it all takes place on a special switch we call a border leaf. And you've got some real flexibility here. You can use a simple, standard Layer 3 routed interface, or if you're dealing with multiple tenants or VRFs, you can use sub-interfaces. And there's also the option of using a switched virtual interface, an SVI, which is super common when you're connecting things like firewalls. And here's the great news. ACI doesn't try to reinvent the wheel when it comes to routing. It plays nice with all the standard protocols you already know and use: OSPF, BGP, EIGRP, even good old static routes. This is a massive plus because it means you can slide your ACI fabric into your existing network without a huge headache.
Okay, so we've got the physical connection on the border leaf. We've picked our routing protocol, but how does the information actually travel? How do routes get in and then get distributed throughout the rest of the fabric? Let's follow the data.
This is where the real magic of the ACI fabric kicks in. So imagine a route comes in from the outside world on that border leaf. Let's say it's an OSPF route. The border leaf immediately takes that route and redistributes it into ACI's internal control plane, which is all based on multi-protocol BGP. The spines act as route reflectors for this MPBGP, and just like that, that external route is instantly blasted out to every single leaf in the fabric. Pretty cool, huh? It ensures everyone knows how to get out.
But that's only half the story, right? That's getting routes in. What about telling the outside world about our internal networks? Well, this part doesn't happen automatically, and that's a good thing. It's all about control. ACI forces you to make a conscious policy decision about what you're going to advertise.
So step one is a really simple but super important checkbox, basically. You go into the bridge domain where your application's subnet lives, and you have to explicitly mark that subnet with the scope advertised externally. By default, everything is private. This is you literally raising your hand and telling ACI, hey, this subnet right here, it's okay to share this one.
And then comes step two, which gives you incredible control. You take that same bridge domain and you associate it with a specific L3 out. Think about what that means. You could have two L3 outs, one going to your private WAN and one going to the internet. You can choose to advertise your service subnet to the WAN, but not to the internet. That's some seriously powerful and granular control over your routing advertisements.
Okay, so we get the theory. But what does this actually look like when you're building it? Let's break down the main policy objects you'll be configuring in ACI. Really, it boils down to 4 core tasks. First, you create the main L3 out policy itself. Second, you make sure the MBGP route reflectors are enabled. That's the internal magic. Third, you configure your bridge domain to advertise the subnets. And fourth, the step everyone forgets, you have to configure a contract to actually allow the traffic.
Let's look at the L3 out policy itself. This is where you'll put all your classic routing protocol details. So if you're building an OSPF L3 out, you'll specify the VRF, the OSPF area ID, and the area type. If you're doing BGP, this is where you'll define your peer addresses, your AS number, and all those BGP-specific controls.
Now, inside that L3 out, you have to define something called node and interface profiles. This is a really key ACI concept. It's how you connect the logical, your routing protocol settings, to the physical hardware. The node profile says, okay, which specific border leaf switch are we using? And the interface profile says, and on that switch, which exact port or SVI are we using for this connection? It's that mapping from logic to physical.
Okay, this next part is absolutely critical to understanding how ACI thinks. Just because you have a route, it doesn't mean a single packet is going to flow. Before we can permit traffic, we have to classify it. We need a way to label the traffic coming from the outside world so we can apply rules to it. And the tool for that is called the External Endpoint Group, or External EPG. All it is a logical bucket. It's a container where you can put one or more external subnets. By grouping them like this, you can then apply a single security policy or a contract to that entire group of external networks.
The most basic way to do this is to create one external EPG and put the subnet 0.0.0.0/0 in it. That's a catch-all. It basically means anything and everything on the outside. This is perfect for a simple internet connection where you just want to apply one set of rules to, the internet.
But here's where it gets really powerful, and the documentation calls this out specifically. You don't have to use just one big catch-all group. You can create multiple external EPGs for different, more specific external subnets, and then apply different rules to each one. And this table is the perfect example of how that works. ACI uses the classic longest prefix match rule. So look at that traffic coming from 192.168.1.1. Technically, it matches the /16 in EPG1, and it matches the /24 in EPG2, but it also matches the /32 in EPG3, and because that is the most specific match, ACI will classify that traffic as part of EPG3 and apply contract 3. This is huge for creating really granular security policies for different partners or services out on the internet. So we keep talking about contracts. Let's make this crystal clear, because this is the final non-negotiable step to actually getting packets to move through your L3 out. I'm telling you, this is the #1 thing that trips up engineers who are new to ACI. You'll spend hours troubleshooting. You've configured your OSPF, the neighbors are up, you see the routes being exchanged, you can even ping from the border leaf to the external router. Everything looks perfect. But you go to your actual application server and nothing. You can't reach the external network. What gives? And here's the fundamental truth of ACI. It is a zero-trust system. It's a whitelist model. Having a route in the routing table only tells you that a path exists. It does not give you permission to use that path. I'll say it again. Routing is for reachability, contracts are for permission. Without a contract, ACI denies the traffic. Period. So you have to explicitly create that permission slip. You do this by creating a relationship between your internal EPG and that external EPG we just talked about. One side provides the contract, the other consumes it. So for example, your internal web server EPG would provide a contract that says, I offer web services on TCP ports 80 and 44.3. Then, your external EPG that represents the internet would consume that contract. That's the handshake that explicitly allows that specific traffic to flow. Okay, enough theory. Let's put all these pieces together and walk through a complete end-to-end example using OSPF. This diagram really pulls everything we've talked about into one picture. On the left, you've got your internal app living in its own EPG. And way over on the right, you have some external network we need to talk to. So, let's follow the routing information that makes this connection happen.
So, look at the flow here. First, our internal subnet, the one we marked advertised externally, gets redistributed by the border leaf and sent out into the OSPF domain. At the same time, the border leaf learns about the external route from its OSPF neighbor. It then takes that external route, injects it into the fabric's internal MPBGP, and the spines shoot it out to every other leaf. Boom. At that point, your control plane is fully converged. Everyone knows how to get everywhere.
Okay, we've gone through a ton of detail here, so let's zoom out. What are the absolute key takeaways you need to remember when you go to build your own L3 out? Let's boil it down to 4 crucial points. Number 1, the L3 out is your bridge. It's the only way to do external layer 3 connectivity. Number 2, routing is a two-way street. You have to think about getting routes in and getting routes out. Number 3, and this is the big one, policy is paramount. Routing is reachability, contracts are permission. No contract, no traffic. And finally, number 4, external EPGs are your tool for classifying external traffic. Use them to group subnets so you can apply those contracts with laser-like precision. If you get those 4 things, you've totally got this.
And that really leaves us with one final thought. Building the L3 out, getting the routing to work, that's just step 1. That's just building the bridge.
The real work of an architect and the true power of ACI is in designing the smart, granular, zero-trust contracts that make sure that bridge is secure. So the question is, how will you design yours? Thanks for tuning in.